Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on October 14, 2025, which was about 2 days ago. The striking result is a multimodal search model that outperforms retrieval augmented generation workflows by 21.13 and beats prompt-based search agents by 8.89 while remaining competitive with GPT-03 and surpassing GPT-4o on several tasks. The paper is titled DeepMMSearch-R1, Empowering Multimodal LLMs in Multimodal Web Search, and as we will see later, the gains come from smarter, more selective tool use. Beyond raw scores, the model conducts on-demand multi-turn web searches, uses targeted image crops, refines text queries, and learns via supervised fine-tuning plus online reinforcement learning. Alright, the previous segment summarized the headline gains. Figure 1 contrasts prior search-equipped multimodal large language models with DeepMMSearch-R1. The left panels depict failures from missing self-reflection and ineffective image search, because whole image queries retrieve noisy results and misidentify the bird. The right panels show targeted cropping plus iterative query refinement, which extract cleaner evidence and produce correct answers. The bottom bar chart reports average performance, where DeepMMSearch-R1 surpasses GPT-4o and MMSearch-R1 and comes close to GPT-03. Okay, Figure 2 presents the data generation pipeline and the resulting dataset statistics. The top pipeline shows Gemini producing reasoning and an action tag, passing checks A, B, and C, then calling text search, grounding DINO, or image search, with summaries returned in an information block before the final answer and reason tags. The left chart summarizes the knowledge taxonomy. The center bars report conversation length, with most examples needing 1 to 3 assistant turns. The right donut shows tool usage, where text search dominates and cropped image search forms a smaller slice. Alright, Figure 2 set up the data and tools. Table 1 now compares accuracy across 6 VQA benchmarks. The web-equipped block shows DeepMMSearch-R1 with reinforcement learning averaging about 57, which tops the prompt-based search agent near 51 and clearly exceeds the retrieval workflow around 41 to 47. The gains persist across datasets, and direct answering even beats retrieval on OKVQA and AOKVQA because unnecessary web results add noise. The supervised model already helps, while reinforcement learning delivers the largest bump. So, Table 1 showed the accuracy gains. Figure 4 tracks how the model actually uses tools. The charts compare supervised fine-tuning with reinforcement learning on dynamically and OKVQA, which reveals heavier tool use on dynamically overall. Reinforcement learning increases image and mixed searches, and it prompts more query refinements by about 2%. At the same time, cropped image searches drop sharply by roughly 37 points on dynamically and 35 points on OKVQA, which signals more selective behavior. So while Figure 4 tracked tool usage shifts, Figure 3 summarizes where the gains come from. The left panel shows bars for SFT base, plus multi-turn search, and plus cropped image search, with average improvements of about plus 1.5 and plus 1.8, and especially larger boosts on simple VQA and dynamically. The right panel reports the fine-tuning mix, where a balanced 50-50 split of search required and search-free data yields the best overall accuracy. Well, Figure 3 summarized where the gains originated. Figure 5 shows how reinforcement learning changes cropping behavior. The left panels under SFT depict large, unnecessary crops that include distracting background, which often led to noisy image search. The right panels under reinforcement learning display tighter, selective crops around the true object, like insects, birds, and fish, so searches retrieve cleaner matches. The contrast illustrates more efficient tool use because cropping occurs only when it helps. Alright, 2 takeaways stand out. Smarter, selective tool use drives the gains, with targeted image crops and iterative text queries reducing noise and lifting accuracy. And the supervised fine-tuning plus online reinforcement learning recipe reliably teaches that behavior. The implication is practical multimodal web agents that stay current, search less, and answer better. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.